Welcome. In this video, we're going to be doing example 1 from lesson 12 from module 2 for grade 7. We're going to be talking about integer division. I want you to think back to the rules we have that relate multiplication and division. Remember, multiplication is repeated addition, division is repeated subtraction. So multiplication and division are opposites, they're related expressions. If I were to take a look at some equations that are all related with multiplication and division, I could look at the equation 4 times 6 equals 24. Another multiplication equation that's related to this is 6 times 4 equals 24. I'm using all three of the same numbers. I could also write a division problem that uses these three numbers. 24 divided by 6 equals 4, or 24 divided by 4 equals 6. All four of these equations are related. They use the same three numbers, 4, 6, and 24, just in different orders. Now, these equations all have positive numbers in them. I could do the same sorts of equations with integers. I can look at negative 6 times 4. That gives me negative 24. Remember from our rules of multiplying, if the two signs are opposites, or the numbers have opposite signs, then we get a negative number. I could also see negative 4 times 6 equals negative 24. So that commutative property again says that if we change the order of the opposites, we still have a negative sign. And then we've got negative 4 times negative 6. This gives us positive 24. Remember, when we multiply integers with the same sign, we get a positive answer. Now, these are the multiplication problems that are using integers that go with this basic family of facts. Let's see what happens when we add division into it. If I were to write division problems related to this particular multiplication problem, negative 6 times 4 equals negative 24, this is what I get. I can either do negative 24 divided by negative 6 equals positive 4, so negative 24 divided by negative 6 equals positive 4, or negative 24 divided by 4 equals negative 6. I'm still using the same three numbers. I'm just changing them into a different fact. Now I can look at the same for negative 4 times negative 6 equals negative 24. I get negative 24 divided by negative 4 gives me positive 6, and negative 24 divided by positive 6 gives me negative 4. Same numbers as in this multiplication equation, just rewritten as division problems. And the last multiplication problem can be rewritten as division in this way. 24 divided by negative 6 gives me negative 4, and positive 24 divided by negative 4 gives me negative 6. Again, same three numbers, just rewritten as division problems. Every multiplication problem gives me two related division problems. I want to go over some terminology for division real quick. This first number in a division problem is called the dividend. It's the number being divided. The second number in a division problem is called the divisor. It's the one we're dividing into the dividend. And the last number in the answer to a division problem, that's the quotient. So as we talk about those, we're going to be using the terms dividend, divisor, and quotient. In part A, we're going to list examples of division problems that produced a quotient, an answer, that is a negative number. And you can see I've got 4 of those. Negative 24 divided by 4 gives me negative 6. Negative 24 divided by positive 6 gives me negative 4. And then my 2 from the last part here, positive 24 divided by negative 6 gives me negative 4, and positive 24 divided by negative 4 gives me negative 6. In here, my quotient, my answer, is all negative numbers. But you can see each division problem is a little different. So if we look at all of these, if the quotient is a negative number, what must be true about the signs of the dividend and divisor, the two numbers being divided? If I look at all of my dividend divisors and I look at their signs, I have negative and positive, negative and positive, positive and negative, positive and negative. So it looks like the two signs have to be opposite of each other. One of them needs to be positive and one of them needs to be negative. So the quotient is a negative number when the signs of the dividend and the divisor are not the same. They're opposites. One is positive and one is negative. Let's take a look at what happens when my quotient is a positive number. Here are some examples of division problems that produced a quotient that is a positive number. 24 divided by 6 gives me 4. That was from the bubble on the left. 24 divided by positive 4 is positive 6. Negative 24 divided by negative 6 gives me a positive 4. And negative 24 divided by negative 4 gives me a positive 6. If we wanted to look at these as an example from the card game, if I had a total of 24 and I had 6 identical cards, each one of those cards would have to be a 4. Or if I had a total of 24 and each one of those cards was a positive 4, I'd have to have a total of 6 cards. In negative 24, if I had a total of negative 24 and each of those cards was a negative 6, then I would need 4 cards. If I had negative 24 and each of those cards was a negative 4, then I'd have to have a total of 6 cards. So we can look at that from the example of the card game. All of these quotients are positive, however. I had 4 cards, I had 6 cards, 4 cards, and 6 cards. And what's true about the signs of all of these dividends and divisors? If I look, then I can see that my dividends and divisors here are both positive. Here, they're also both positive. In this problem, they're both negative, and in this problem, they're both negative. So in order to get a positive quotient, it looks like we need to have our dividend and divisor be the same sign. So the quotient is a positive number when the signs of the dividend and the divisor are the same in each case, either both positive or both negative. So we can write the rules for dividing two integers as a quotient is negative if the divisor and dividend have opposite signs, either one positive and one negative, and a quotient is positive if the divisor and the dividend have the same signs, both positive or both negative. These are the same rules we came up with for multiplying. Since multiplying and division are inverses of each other, they're opposite operations, then that makes sense. The same process or the same rules apply for both multiplication and division. All right, that's the end of this video. Make sure everything's filled out. Watch it again if you don't quite understand what's going on, and we'll see you in class. Bye.